Hi students, in this lecture I am going to discuss problems based on rolling. Let us see. A disk of mass 2 kg and radius 4 meter is rolling without slipping on a horizontal rough road. A horizontal force of 4 Newton is applied at a height of 1 meter above the center. Find the frictional force acting on the body. So given disk mass 2 kg, radius 4 meter, given horizontal and rough, applying a horizontal force of 4 Newton at a height of 1 meter above the center. Right, let us see how to start the problem. Right, first note down the given data. See the data given. It is a disk. Disk of mass. See how much given mass here. Disk of mass 2 kg. It is a disk. Radius 4 meter. Radius 4 meter. And applying a force of 4 Newton above the center at a height that is given now 1 meter, and that force is 4 Newton. See once force 4 Newton, mass 2 kg, radius 4 meter at a height 1 meter above the center. So we have to calculate now frictional force. Ground is given rough and horizontal. Condition when rolling without slipping, right? So first of all, we have to focus whenever question is given on rolling. It is a combination of a translation and rotation. So translatory motion of center of mass and rotation about center of mass. So for translation, we take force equation, and for rotation about center of mass, we are taking torque equation. Let us see now how many forces acting on the body. Frictional force at this contact, it may be zero, or if it is not zero, it may be right side or it may be left side. Okay. So since we are not knowing that, we can take any direction that is our choice. Suppose I am taking it is right side. It is a completely our choice. It is right side. Since it is now rolling without slipping, it will be static. It is F. Okay. Let us now focus on force equation for translator motion. Then we assume all forces are acting at center of mass. So applied force 4. We are assuming frictional force acting forward. Therefore, net force 4 plus Fs. This is net force which is equal to mass into acceleration. And see what is now mass given 2 kg into acceleration of center of mass. So equation 1. Right. Next. Now taking torque equation about center of mass. So taking equation for center of mass and torque equation about center of mass. You can see because of applied force, torque will be clockwise about center of mass. And because of friction, torque will be, it is anti-clockwise, right? If you assume that torque clockwise as positive, it is a complete our choice. I am writing here, taking clockwise a torque as a positive. Then see torque due to applied force. 4 distance equal to 1. 4 into 1. Okay. Next, because of frictional force, torque about center of mass is anti-clockwise. So since clockwise is positive, anti-clockwise will be negative. So minus Fs into R and R value 4. This net torque is equal to I into alpha. Means we are assuming that body is now rolling. It is a clockwise. Okay, moving right side. Therefore, net torque is clockwise. That is equal I into alpha and I value mr square by 2 disk m r square by 2. This is I value about its own axis mr square by 2 into alpha. Let us see once number of unknowns. Frictional force, ACM and alpha. Three unknowns. Three unknowns. So we require now one more condition. Okay. Then see what we can do. Now we have to focus relation between alpha and ACM, right? Since it is now rolling without slipping on ground, for contact point velocity should be same as that of contact surface. It is now ground. So its velocity must be equal to 0. So velocity 0 means VCM minus R omega should be equal to 0. If you differentiate this, we get ACM is equal to R into alpha. This is our next condition. Okay. So we have three unknowns and we got three equations. Now see in the place of alpha, we can write it is ACM by R. Okay. The R value how much? 4. So it is now 4 alpha. So I'm taking that in equation 2. Then see what we get. First of all, we can cancel here 4, 4 and 1, 4 here, right? Because of 4 square m r square by 2 and 1, 2 that's cancelled. Remaining is here from equation 2. From equation 2, see it is 1 minus Fs. It is equal to what else left here? Only 4 is left. Okay. 4 in the place of alpha ACM by 4. Okay. ACM by 4. 4, 4 cancel. Okay. Right. Now in the place of ACM, we got 1 minus Fs. Take this one. Take this one in equation 1. Okay. In the place of ACM. So from equation 1, 4 plus Fs. 4 plus Fs is equal to, in the place of ACM, I am writing 1 minus Fs. Okay. Now see what we get. This is 2 minus 2Fs. If I'm taking this 2Fs this side, Fs and 2Fs, it becomes 3Fs, right? 3Fs. That is equal to, I'm taking 4 here. Then see what happens. 2. Just let me cross check once equations what I have written. 4 plus Fs equal to into m into ASM, right? Next here we have taken that Force is acting in the same direction. That means torque 4 into 1 minus Fs into 4 equal to r square mr square by 2, right? Into alpha. In the place of alpha, we are writing ACM by 4, right? Okay. Next is calculation part. So in this, what we are going to get, I have done calculation 4, 4, and here 1, 4 cancel, 2, 2 cancel, 1 minus Fs equal to 4, 4 alpha, right? 4 alpha in the place of alpha, ACM by R, 4 cancelled. ACM equal 1 minus Fs. ACM. This is now 2. 2 into 1 minus Fs. 2 into 1 minus Fs. Minus 2Fs. Taking here 3Fs. This is a 4. Coming to here minus 4. 2 minus 4. It is minus 2. 2 minus 4 minus 2. That means Fs equal to minus 2 by 3. Right? Fs equal to minus 2 by 3. And remember, we have taken frictional force is right side, but we got here negative sign, right? Negative sign means it indicates that frictional force is now left side. Okay, that's why we can take any direction and make that calculation, right? So minus indicates it is left side. That means its value 2 by 3, direction left side. Okay, so here we have to keep in mind that this frictional force depends on how much force is applied and at which location this force is applied. Okay, at which location this force is applied means for same force, if you are changing the point of application, frictional force may change. Okay, let us do one thing. Suppose same problem. At what height this force must be applied? At what height this force must be applied so that no frictional force acts on the body. Okay, let us take this as a height h, which we have to calculate. Okay, so I'm taking this height as h, which is unknown, right? Let us see what happens. We want to calculate h value. For what? For frictional force should be 0. Okay, right. Now see where change comes in equations. Coming to force equation. Applied force becomes now net force. What I'm saying is applied force becomes now net force because frictional force is 0. For that, we have to find h value. Okay. So first equation 1 becomes now 4 equal to mass into acceleration. Equation 1. Next, coming to torque equation, no frictional force, only applied force. So 4 into h equal to I into alpha, m r square by 2, mr square by 2 into alpha. In the place of alpha, I am writing ACM by r value 4. Okay, so 1, 4 cancelled here, remaining 4 cancelled here, 2 and 2 cancelled. ACM equal to h, right? ACM equal to h, use that in equation 2. Okay, now equation 2. 2 here, 2 times. So ACM, we got how much? 2. ACM 2, take here ACM 2. That means H value how much? It is 2 meter. Is a point clear? You just observe where change is coming. In equation 1, no frictional force. So F is net force. So ACM how much? 2 directly. Next here, no friction. So no torque due to friction, right? So 4 into H. 4 in the place of 1, taking H. 4 into H equal to mr square by 2, right? That means if we apply force at a height 2 meter above center, then no friction acts on that body. So here simply focusing on force equation for center of mass, torque equation about center of mass, then solving those two. Then we are going to get the answer, right? For example, same force if you apply below center of mass. Okay, let us see. If you take same force applying at same distance 1 meter but below center of mass, see what is the force. Okay, let us make calculation here. So we want to take same force, same distance from center, but distance 1 meter below the center. Right, now take here. So I'm taking the same problem, just I'm changing now the point of application of force. So applying force at a distance 1 meter below center. Okay, again all values are same. Just see where change comes. If we assume that still force is acting right side, because we are not knowing in which direction frictional force acting, assume that frictional force acting, it is now left side. So we can take right side, no issues in that. It is right side. Take it as F. So first equation, no change. F, that is a 4 plus frictional force equal to M into AC. Okay, in this no change. But remember, when body is rolling, definitely rotation will be clockwise. Means alpha will be clockwise, right? Because net force is right side. So VCM right side, ACM right side. When ACM right side are alpha, alpha must be clockwise. Okay. But according to this, because of applied force, torque anti-clockwise. Because of friction also, torque is anti-clockwise. Okay. So equation here, what I'm writing, 4 into 1, that is anti-clockwise, plus F into 4, again anti-clockwise, again anti-clockwise. If you take clockwise a positive, then this will be negative. Or if you take anti-clockwise a positive, clockwise will be negative. So M R square, M R square by 2 into alpha. I am writing here minus alpha. Why minus alpha means alpha is now clockwise. Alpha is clockwise. But torque is now anti-clockwise. That's why if this is a positive, alpha must be negative. Okay. Now see carefully. Calculation part. 4, 4 and 1, 4 gets cancelled. 2 and 2 cancelled. 1 plus F is equal to 4 is here minus alpha in the place of alpha. What we have right? R alpha equal to ACM, right? Alpha equal to ACM by R. ACM by R. And this is minus, don't miss this one. 4, 4 cancel, right? Now see what we get here. ACM equal to minus of 1 plus F. Okay, ACM equal. Substitute that in equation 1. Substitute that in equation 1. 4 plus F is equal to 2 into minus 1 minus F. Okay. ACM equal to minus 1 minus F. Simplify this. Minus 2. Take this side. 4 plus 2, 6. Plus F. Here, what else left? Minus 2f, right? Minus 2f means if you take here, it becomes 3f. 3f equal to 0. That means, let me cross check once calculation here. Minus 2, taking here minus 2. Minus 2 means becomes plus 2. So 6. This is f minus 2f and f minus 3f. So f equal to minus 6 by 3. It is 2 minus 2. This minus indicates now frictional force is left side. Then only, if you observe carefully, then only net torque will be clockwise. Get the point. So even though we have taken frictional force is right side, we got a value negative. So frictional force is left side. Because of frictional force, torque is now clockwise. Because of applied force, torque is anti-clockwise. So net value is clockwise. So alpha is clockwise. Then we can take ACM equal to R into alpha. So like this, same force is applied here and here. But if you apply at same distance below center, frictional force we got here 2, right? In the previous case, we got, I think, minus 2 by 3, right? So like this, frictional force depends on where force is applied. At the same time, how much force is applied. And here we have seen frictional force is 0. That means frictional force may be 0, may be non-zero. Whenever body rolling without slipping, if friction is non-zero, it will be static, right? That may be forward or that may be backward. Depends on point of application of force and how much of force is applied, right? So I hope you got a clarity.